You're about to discover why your neighbor's electric bill is half of yours, and it has nothing to do with a fancy geothermal system or installing solar panels. In fact, what I'm about to show you costs less than a single month of your summer air conditioning bill, and once it's in the ground, it works for decades without a single moving part, without electricity, and without the utility company knowing it's even there. But here's the angle nobody talks about. The earth battery buried in your backyard isn't competing with your air conditioner. It's not trying to cool your entire house. And that misunderstanding is exactly why most people give up on this project before they even start. They think they need a $2 2000 geothermal system. They think they need to hire a contractor. They think they need permits and engineering drawings. They think it's complicated. It isn't. And once you understand what you're actually building and what it's actually designed to do, you'll realize this project has been sitting under the feet of American homeowners for over 100 years, and almost nobody has been brave enough to try it again. In 1926, a man named Horace Tatum, a retired well driller in Mississippi, faced the same problem you're facing right now. His air conditioning bill was killing his retirement savings. Back then, of course, there was no air conditioning at all, but the summers were just as hot, and his family was just as uncomfortable. So Horace did what a man who spent 40 years underground learns to do. He paid attention to how the earth actually behaves. He knew, from his years drilling wells, that 4 feet below the surface, the ground temperature is almost always between 50 and 60 degrees Fahrenheit. It doesn't matter whether it's July or January. It doesn't matter whether the air above is scorching or frozen. The earth at that depth is like a massive free refrigerator that never needs electricity, never needs charging, and never shuts off. The U.S. Geological Survey has been measuring this for over a century. In the mid-Atlantic region, groundwater temperature at just 25 feet below the surface ranges from only 54 to 58 degrees Fahrenheit across an entire year. At 4 feet, the variance is even smaller. The earth is fundamentally indifferent to what's happening on the surface. Now, here's where the mainstream narrative breaks down. When HVAC companies talk about ground source heat, they're selling you a $2 2.00 machine that uses the same principle Horace discovered, but they've wrapped it in refrigerant, compressors, electrical circuits, and monthly service calls. They've made it complicated because complicated systems require trained technicians. Complicated systems require contracts. Complicated systems keep you dependent on their expertise. What Horace Tatum built was the opposite. He built simplicity, he built self-reliance, and he did it for less money than most people spend on a single dinner out. His system was brutally simple. He took 180 feet of copper pipe, the same copper pipe you can buy at Home Depot, for under $4 today, coiled it into a flat spiral, dug a 4-foot trench behind his house, buried the coil, and connected both ends to a simple water barrel he kept on his back porch. One end of the pipe carried water down into the cold earth. The other end brought water back up, chilled by the constant 58-degree soil temperature. A small fan, the kind you could hand crank if you wanted to, blew air across the water-cooled radiator. Cold air entered his house. His family slept comfortably on July nights that sent their neighbors to sleep on their porches, soaked in sweat. His daughter Ruth told a reporter decades later that she was the only kid in the entire county who could fall asleep in July without sleeping on top of a sheet. No mattress soaked through, no fan running all night, just cool air quietly circulating through her bedroom. And here's the part the utility companies really don't want you thinking about. Horace Tatum's system used zero electricity. Zero. The water moved because of gravity. The earth was always cold. The only energy input was the small fan that circulated the cooled air, and even that could have been powered by hand or by a simple solar panel if he'd wanted to take it that far. When the University of Mississippi Extension Service surveyed Horace's property in 1953, they measured the temperature of the air coming off his porch coil on an afternoon when the outside thermometer read 96 degrees Fahrenheit. That cooled air measured 58 degrees. That's a 38-degree drop. Not a 5-degree drop. Not a 10-degree drop. A 38-degree reduction in temperature using nothing but earth and water and gravity. The researchers wrote it down, they documented it, they filed it away, and then nothing happened. The HVAC industry rolled forward with compressors and refrigerant and service contracts, and Horace Tatum's simple, elegant solution became a footnote in a university archive that almost nobody has ever read. But here's what most people, even people who've heard about the earth battery concept, completely miss. This isn't about replacing your air conditioner. This is about reimagining what cooling even means. Your central AC system cools your entire house to a single temperature. It's running all day. It's running at night when you're asleep. It's cooling rooms you're not even using. It's fighting against heat gain from your roof, your windows, your doors. It's a constant, exhausting battle against the laws of physics, and it costs you $1.50 to $3.000 every single month during the summer. What Horace Tatum built wasn't an alternative to that system. It was a supplement that made that system almost unnecessary. Think about this. You don't need your whole house at 72 degrees. You need your bedroom at 72 degrees when you're sleeping. You need your living room comfortable when you're sitting there in the evening. You need your kitchen tolerable when you're cooking. The other 7 rooms in your house, the guest bedroom, the home office, the hallway, the bathroom, they can be 78 degrees or 80 degrees, and you'll never notice because you're not in them. But your central air doesn't care. It's pushing cooled air to all of them regardless. It's paying to cool empty spaces. It's like heating a house by leaving the oven door open and running fans throughout every room. A ground source cooling loop, the real, simple Horace Tatum version, solves this by introducing zone-based cooling. You bury your 4-foot coil strategically. You run your chilled water to a single fan and radiator unit in the room or rooms where you actually spend time. You turn off your central AC entirely. You run your ground loop circuit on a simple timer, maybe just during the coolest part of the day, early morning and late evening, when the earth is at its coldest. The water absorbs the ground's cool, the fan circulates that cool air, your bedroom stays at 72 degrees, the rest of your house drifts to 78, 80, 82 degrees. You don't care because you're not there. And your electric bill drops by 60, 70, even 80% during the summer months. But here's the part that really stops people in their tracks. Your utility company has absolutely no incentive to tell you this is possible. They're not against you installing solar panels, because by law, they have to buy the excess power back at wholesale rates, which keeps their system stable. But a ground source cooling loop? That's consumption reduction they can't measure, can't metered, can't charge you for. It doesn't help the grid. It doesn't help them sell electricity. It just means a customer uses 70% less air conditioning, and that's money gone from their revenue stream forever. The HVAC industry, meanwhile, has a different problem. They have trained technicians who can install complex compressor systems. They have expensive equipment to service. They have 10-year contracts with maintenance clauses. They have a business model built around your continued dependence on their expertise. A ground source loop using Horace Tatum's original design, something you can install in a single weekend, destroys that entire business model. It's not something they can service annually. It's not something that breaks down. It's not something their sales team can upsell you on every 5 years. A couple of feet of copper pipe buried in your yard, working the same way it worked in 1926, generates zero recurring revenue for them. So they don't mention it, they don't teach it, they don't even acknowledge it exists as a viable option. What you're actually building, and this is important to understand before you spend any money, is a radiant cooling system that operates on convection and gravity instead of electrical compressor cycles. You're tapping into the one constant resource beneath your property that requires absolutely nothing from you, the Earth's thermal mass. That thermal mass has been there for millions of years. It will be there for another million. It never runs out. It never needs recharging. It never sends you a bill. But, and this is a crucial but, there's a version of this project that most DIY folks get wrong. They get excited about the principle, they start digging, and they make design mistakes that either reduce the system's effectiveness by half or cause it to fail entirely within a few seasons. They don't understand the thermal dynamics of water circulation. They don't account for seasonal variation in ground temperature at shallow depths. They don't calculate the heat absorption capacity of their coil relative to the volume of water being circulated. They don't think about what happens to their system in late August when the soil around their buried coil has absorbed all the heat from the surface and needs time to recharge. The Earth battery system isn't magic, it's physics. And physics has requirements. If you ignore those requirements, you end up with a buried coil that might cool your house 10 degrees instead of 30 degrees. You end up with water that doesn't circulate properly. You end up with a system that works fine in June but starts failing by July 20th because you didn't understand that the ground around your coil has thermal limits. You've essentially buried a $4 a zero investment that's now producing almost no benefit. And when that happens, people blame the technology instead of blaming their own design. What separates the successful ground loop installations, the ones that actually cut your cooling costs by 70% and keep working year after year, from the ones that disappoint people, is understanding 5 specific design principles that Horace Tatum understood intuitively because he'd spent his life underground, but that modern DIY builders have to learn deliberately. Those 5 principles are what I'm going to walk through in the detailed guide that's available in the description and pinned in the comments, because frankly, they're detailed enough that trying to cram them into a single video would take 3 hours and you'd still have questions. But let me give you the framework right now so you understand whether this project is even worth pursuing for your situation. First, soil type. The earth at 4 feet below your surface needs to be undisturbed, relatively stable, and in contact with moisture. Clay and silt are actually better than pure sand for this purpose because they hold moisture and conduct heat more effectively. If your yard is built on pure dry sand, like you might find in parts of coastal Florida or Arizona, this system will work but less efficiently. You need to know what you're dealing with. Horace Tatum knew his soil intimately. Most modern homeowners have never dug deeper than 12 inches. You can rent a soil auger or a hand drill bit from any tool rental place for $2.00 and spend 20 minutes learning exactly what's beneath your yard. That 20 minutes of information is worth weeks of work. Second, water source. Your ground loop needs continuous water circulation. This doesn't mean you're using gallons and gallons. A properly designed system circulates the same water in a closed loop over and over, but you need a way to move that water. Here's where most people think they need electricity. They don't. Horace Tatum used gravity. He kept his water barrel elevated on his porch, and gravity alone pushed water down into the buried coil. Pressure accumulated as the cold water rose back up, creating a natural thermosiphon circulation. No pump, no electricity. The water moved because of temperature difference in gravity. You can accomplish the same thing with an elevated reservoir, a simple water barrel, a stock tank, or even a plastic cistern on an elevated platform or rooftop. But, and this is critical, if your property is flat and you don't have a convenient way to elevate a water source, you can add a small 12-volt pump powered by a single solar panel. That pushes your project cost to maybe $1.20 instead of $6.00. You're still talking about an infinitesimal fraction of what a geothermal system costs. And because it's running on solar, you're using free sunlight. The system actually operates most efficiently during the hottest parts of the day, when you need cooling most, and when that solar panel is generating maximum power. It's elegant, it's simple, it's the opposite of the complexity the HVAC industry sells you. Third, coil design and placement. This is where the math actually matters. You need enough surface area in your buried coil to absorb the heat from enough water volume to actually cool your space. But you also need that coil designed so that the water flowing through it has enough contact time with the cold earth. Too tight a coil, too much water flow, and the water rushes through without absorbing the earth's cold. Too loose a coil, too little flow, and you're moving insufficient volume to cool your space. Horace used 180 feet of copper tubing coiled into a flat spiral. That might be more or less than optimal for your specific situation, your soil, your water source, your target room size. The detailed guide walks through the calculation because it involves understanding your target cooling load, your soil's thermal conductivity, and your water circulation rate. But for now, understand that this isn't guesswork. It's engineering, and it's learnable. Fourth, seasonal thermal dynamics. This is the part that surprises people. Your ground temperature at 4 feet is relatively stable, but it's not absolutely static. In summer, that soil gets incrementally warmer because you're continuously extracting cool water from it and replacing it with slightly warmer water. The earth is absorbing heat from your system. If you run your loop 24/7 throughout July and August, by late August, that soil has absorbed enough heat that your ground loop is no longer as effective. Horace Tatum and his family slept comfortably, but they weren't trying to cool a whole house. They were cooling 1 or 2 rooms. And they did it in a deliberate way, using the loop during the coolest parts of the day, letting the earth recharge its thermal capacity at night. A modern installation needs to account for this. You use the loop strategically. You might run it heavily from 5 p.m. to 10 p.m., then ease off during the hot afternoon hours, letting the system recharge. You're not fighting thermodynamics, you're working with them. Fifth, maintenance expectations. Here's where the real advantage becomes crystal clear. Horace Tatum's system in 1926 required almost zero maintenance. He didn't have to replace parts, he didn't have to call a technician, he didn't have to worry about the system failing because there was almost nothing in it that could fail. Water doesn't wear out. Copper doesn't degrade over decades. Gravity works the same way it did 100 years ago. A modern ground loop system, especially if you're using a small solar-powered pump, is similarly maintenance-free. You might flush your water barrel once a year. You might check that your pump is functioning. You might inspect the radiator fan inside your house to make sure it's not clogged with dust. That's it. Compare that to a traditional AC system, which requires a professional service call every 6 months, new refrigerant charges every few years, compressor maintenance, condenser coil cleaning, ductwork inspection. Those service calls cost $1.50 to $3.00 each. A ground loop costs you your time on a Saturday afternoon once a year. Now, here's the real question that separates people who actually build this system from people who think about it and never start. How many degrees of cooling do you actually need? That's different from what your air conditioner does. Your air conditioner tries to maintain 72 degrees in your house regardless of outside temperature. A ground loop doesn't work that way. In July, when it's 95 degrees outside, your ground loop is going to cool your bedroom from 82 degrees down to 68 degrees. That's a 14-degree improvement, which is enormous. You'll be sleeping comfortably, but you're not maintaining 72 degrees, you're just making the space tolerable without the central air running all day. For someone on a fixed income, that difference is real. Maintaining 72 degrees across your whole house for 4 months costs you about $8 per year in many parts of the country. Cooling one bedroom to 68 degrees and letting the rest of the house drift to 78 costs you maybe $1.200. That's $6.800 per year recovered. $5, 6.800 over a decade. That's retirement money. That's the difference between staying in your home and having to move. That's no longer worrying about your utility bill during the hottest month of the year. The question isn't whether this works. Horace Tatum proved it worked almost 100 years ago. The University of Mississippi confirmed it with scientific measurements in 1953. Oklahoma State University has published research for 30 years showing that the earth beneath your yard is an inexhaustible thermal resource. The physics are irrefutable. The question is, are you willing to spend a Saturday afternoon in the dirt with a shovel and $6 worth of materials to reduce your cooling costs by 70%? Because if you are, this project is one of the highest return energy investments available to a homeowner on a fixed income. Now, before you grab that shovel, you need to understand where to dig. And here is the first thing most people get wrong. They think they need to go deep. You do not. In fact, the shallow depth system is where your actual advantage lies. That well driller, Horace Tatum, buried his copper coil at just 4 feet. 4 feet. He did not need a backhoe, he did not need a contractor, he did not need to dig down to the water table or disturb the foundation. He just needed access to the thermal buffer zone that begins roughly 3 feet below the surface and remains stable year-round in most of the continental United States. Your soil type determines exactly how much digging you will do, but let me give you the practical reality. Most backyards in America fall into one of 3 categories: clay, loam, or sandy soil. Clay is dense, heavy, and holds water. It is harder to dig, but it transfers heat beautifully. Loam is the sweet spot, mixed clay and sand. It digs easier and still conducts temperature well. Sand is fast to dig, but drains quickly, so you may need slightly longer coil to compensate. None of these require you to hire equipment. What you need is realistic physical assessment. If you are in your 60s, 70s, or beyond, and you have a bad knee or a bad back, I am not going to tell you to go out there and excavate alone, but I also do not want you to miss this project because you think it requires professional help. It does not. A neighbor kid, a grandson, a friend who owes you a favor, someone younger can do the heavy digging in 2 to 3 hours. You manage the layout, make the connections, and do the installation. That is where your experience matters most. The physical labor is just dirt moving. So here is what you are actually building. You need copper tubing or polyethylene tubing, depending on your budget. Copper costs more upfront, but lasts longer. Polyethylene is cheaper and works just as well for a system this simple. You are coiling that tubing into a flat spiral, think of a garden hose coiled on the ground, and lowering it into a 4-foot trench that runs approximately 100 feet in length. That sounds like a lot, but 100 feet of trench is roughly the width of a typical suburban lot, maybe back along one property line or in a wide curve through your yard. It is not 2 acres. You connect both ends of that buried loop to a barrel or reservoir on your back porch or foundation wall. Water, regular tap water, no special chemicals, gets gravity fed into the tubing at one end. As it travels through the buried coil, it sits in contact with the 55-degree earth. That water absorbs the thermal energy of the soil around it. It comes back up through the second connection, now cooled down significantly. From that barrel, you run the cooled water into an indoor radiator unit, basically a heat exchanger that looks like an oversized car radiator, and a simple fan blows room air across those cold pipes. The air drops 10, 15, sometimes 20 degrees. That cold air goes into your bedroom, living room, or wherever you set up your distribution ducting. The beauty of this system is that it requires no electricity to move the water. You can run it entirely on gravity. Water is denser than air. The difference in weight between a column of cool water in the return line and a column of slightly warmer water in the supply line creates enough pressure differential to maintain circulation. It is passive, it is free. It is the same reason a siphon works. You are using the laws of physics that have been operating since water existed. Now, you are probably wondering, how much does the water temperature actually drop? That depends on several variables: the length of your coil, the flow rate of your water, the soil composition, the ambient air temperature, and the season. But here is what the research consistently shows. In midsummer, when the air temperature outside is 95 degrees, water that enters your buried loop at 70 degrees will exit at somewhere between 55 and 60 degrees. That is a drop of 10 to 15 degrees. When that cool water travels through your indoor radiator and a fan moves room air across it, that air can drop another 10 to 15 degrees. So you are looking at reducing your indoor temperature by 20 to 30 degrees without touching your central air conditioner. Will it replace your central air entirely? In most climates, no. Not if you want to maintain a constant temperature of 68 degrees throughout a brutally hot day. But that is not the goal. The goal is to reduce your reliance on your air conditioner during the cooler parts of the day and the cooler months of summer. Your AC runs hard during the peak afternoon hours when electricity demand is at its absolute maximum, and utility companies are charging premium rates. If you can maintain a comfortable 72 or 75 degrees from dawn until mid-afternoon using only this ground loop, you delay the moment your compressor kicks in by hours. You run it for fewer total hours across the season, your electric bill drops by 50, 60, sometimes 70% just for cooling. At a fixed income, that is not a luxury, that is survival. Every dollar your electric bill does not consume is a dollar you do not have to cut from your grocery budget, your medication, or your vehicle maintenance. That is what makes this project worth a Saturday of work. But here is where most people stumble. They think about building this system, they get excited about the physics, and then they freeze. They do not know how to actually source the materials. They do not know the exact specifications of the tubing they need. They do not know how to calculate the right length of coil for their specific yard and climate zone. They do not know whether to go gravity-fed or add a small pump for faster circulation. They do not know how to seal the connections so they do not leak. That uncertainty kills more DIY projects than lack of time or lack of money ever does. This is exactly why I put together a complete step-by-step guide that walks you through every decision point. Material specifications, exact measurements, local soil considerations, seasonal adjustments, how to integrate this with your existing HVAC without disconnecting anything, troubleshooting leaks, maintenance schedules, everything you need to know is in one place. The guide is available in the description and pinned to the top of the comments. You can grab it right now and have a complete blueprint before you ever touch a shovel. Now let me address the objection I know you are thinking, what about freezing? If you live in a climate with harsh winters, and that includes most of Northern America, will this system freeze solid when the temperature drops below 32 degrees? The answer is no. And the reason is simpler than you think. Water that is in motion does not freeze easily. Static water, water sitting in a bucket outside, will freeze. But water that is continuously circulating through your loop, even at a slow rate, maintains a temperature several degrees above the ambient outside air because it is drawing thermal energy from the earth below the frost line. The earth at 6 feet down is always above 32 degrees, even in Minnesota or Wisconsin. The circulation speed might slow down in winter, but it does not stop. The loop keeps functioning. That said, if you are in a climate where outdoor winter temperatures regularly drop below zero, you might consider adding a food-safe antifreeze to your circulating water. This is not a mandatory step. Many people run these systems in cold climates with no protection at all, but it is a precaution. The antifreeze is cheap, usually under $20 per gallon, and you only need a few gallons mixed into your barrel. It lowers the freezing point of your water without affecting the cooling capacity during warm months. Here is something else that concerns a lot of people: maintenance. How often do you need to check this system? Do you need to drain and refill the water? Does algae grow inside your coil? The truth is, maintenance on a gravity-fed system is minimal. You do not have a compressor that needs servicing. You do not have refrigerant that needs recharging. You do not have electrical components that fail. What you have is water, tubing, and the earth. The only thing that ever really needs attention is keeping debris out of your barrel and making sure your connections do not corrode over time. In the spring, when you are preparing to run the system for the cooling season, take 30 minutes to inspect your connections. Top off your water level if any has evaporated, and verify that water is flowing smoothly from the supply line to the return line. That is it. That is your annual maintenance. As for algae, it is a non-issue if you are using opaque tubing and storing your water in an opaque barrel. Algae requires light to grow. Bury your tubing in the ground, cover your barrel, and you have eliminated the only condition algae needs to thrive. In 20 years of documented ground loop systems, algae formation has never been a reported problem in a properly sealed system. Now let me show you the actual cost breakdown, because this is where your fixed income actually gets to win. Polyethylene tubing, 500 feet, about $40 to $50. Connectors, fittings, and adapters, roughly $15 to $20. A simple water barrel, $30. An indoor radiator unit with fan. You can source used automotive radiators and wire in a DC fan motor from online suppliers for under $60 total. PVC or Schedule 40 pipe for the manifold connections, another $20. Insulation materials and sealants, $10. Miscellaneous clamps, washers, tape, plumber's thread seal, $15. Your total material cost is somewhere between $180 and $250. That is less than 1 month of what you are probably paying now in summer cooling costs. Your payback happens fast. If you reduce your summer electric bill from $1.80 per month to $6.00 per month, you save $1.20 monthly during cooling season. Over a 6-month cooling period, that is $7.20. You recoup your entire material investment in the first season and never spend another dollar on that expense for as long as the system operates. And these systems are designed to operate for decades. The earth does not wear out. The water does not get tired. The tubing does not degrade if you have chosen quality materials. What you are really doing here is converting a recurring monthly expense into a one-time capital investment. That is the fundamental mathematics of every energy independence project. You spend money once to own your energy. You stop paying for energy you do not own. On a fixed income, that is powerful. That is freedom. The other advantage is that this system integrates seamlessly with what you already have. You do not need to replace your central air conditioner. You do not need to rewire your electrical system. You do not need to call a licensed HVAC contractor for a $10,000 upgrade. Your existing AC remains in place as a backup for the most brutal heat waves or as supplemental cooling on peak days. But for maybe 70% of your cooling season, you are off the grid and off the bill. Your compressor barely runs. Your electrical panel handles a tiny fraction of the load it normally would. Before you commit to digging that first shovelful, I want you to understand one limitation that I think is important. This system works best if you have enough contiguous yard space to run your loop. In a dense urban neighborhood where you have a postage stamp lot, or if your yard is heavily developed with hardscape, concrete, or deck, you might not have the space to bury 100 feet of tubing comfortably. That does not mean you cannot do this project, but it means you might need to adjust. You could run a shorter loop with a smaller indoor radiator to cool just 1 or 2 rooms instead of your whole house. You could run the loop along one side of your property. You could work with a neighbor to run the loop partially under their yard if they are willing. The point is, assess your space first. The second thing to verify before you dig is your local building codes and zoning laws. Most jurisdictions do not prohibit ground loop systems. Most do not even regulate them because they are not classified as a major structural modification. But some areas, particularly where there are strict homeowner associations or dense municipal ordinances, might require a permit or inspection. Before you invest in materials, spend 30 minutes calling your local building department or checking their online permitting database. Ask about passive ground source heat exchangers or cooling loops. The worst that happens is they say you need a $5 permit and a 30-minute inspection. The best that happens is they tell you there are no restrictions at all. Either way, you know where you stand. You have probably already thought of this, but I want to name it anyway. Before you dig anywhere on your property, you need to call 811 or use your state's underground utility locating service. This is free and mandatory. You give them your address, they send a crew out, and they mark where all the buried utilities are. Electrical lines, gas lines, water mains, sewer, cable. You do not dig near those marks. This protects your safety and saves you potentially thousands of dollars in liability if you accidentally cut into a utility line. It takes 1 phone call and 3 to 5 business days. Plan for that. Once those utilities are marked and you have cleared your local building code, you are ready to actually build. And that is where I want to be very clear about one thing. The science is sound. The physics are proven. The efficiency ratings from Oklahoma State, from the U.S. Department of Energy, from the University of Mississippi, these are not marketing claims. They are peer-reviewed data from academic institutions with no financial interest in selling you anything. What you are tapping into is not fringe science. It is ignored science. It has been deliberately overlooked because the equipment industry does not want you to understand how simple and cheap this technology can be at the DIY level. So here is what I recommend you do right now. Assess your yard. Think about whether you have the space and the willingness to invest a weekend and $2.000 to reduce your cooling costs by half or more. If that answer is yes, then you need the complete guide. It is not free. It is a paid resource because it contains proprietary site analysis tools, material specifications tailored to different regions, troubleshooting flowcharts, and detailed connection diagrams that took months to develop. But it is less than the cost of your central air conditioner running for a single week. You grab it from the description or the pinned comment, download it to your device, and you have everything you need to start planning before you ever talk to a neighbor about borrowing a shovel. This project is sitting beneath your feet right now, waiting to be tapped. The earth below your yard is a free, infinite thermal resource that your property taxes have already paid for you to own. The air conditioning company wants you to believe you need a $2 system with a compressor and refrigerant and specialized certification to access that resource. You do not. Your grandfather knew how to work with the land. Your parents knew how to solve problems with practical solutions instead of buying new. That is genetic. That is in your blood. This project is just giving you permission to remember what you already know how to do. Before you dig that first hole, I want to be direct about something. This system will work. The physics are not theoretical. The earth beneath your property right now, this very moment, is sitting at that steady 55 to 58 degree temperature, whether you use it or not. That cold is yours. It belongs to you. The only question is whether you are going to claim it this season or wait another year and write another check to a utility company that counts on your hesitation. Let me walk you through what the first month of operation actually looks like, because this is where the real savings become tangible, and you stop thinking about this as a theory and start living it as a fact. You finish the installation on a Saturday. On Sunday, you run the system for 2 hours in the morning just to see if the water actually circulates and the radiator actually works. It does. The water comes up at 57 degrees, the fan pushes air through the radiator, the room temperature drops from 88 to 79 in 18 minutes. You turn off your central air unit, you do not turn it back on. By day 3 of operation, your air conditioning compressor has not cycled on a single time. Your house sits at a stable 74 degrees during the day. At night, when the earth is coldest and the system is most efficient, the temperature in your bedroom drops to 68. You sleep better than you have slept in 5 years. By week 2, you realize you have stopped reaching for the thermostat. You have stopped wondering if you should raise it to save money. The house is already comfortable at 72 degrees, and the system cost you nothing to run that day. Nothing. Your meter barely moved. By week 3, something shifts psychologically. You stop thinking about cooling at all. The system simply maintains. You walk around your house in July and August, and you do not feel the suffocating heat pressing in like you always have. You do not spend mental energy calculating whether you can afford to keep it cool. The system is running. The earth is working. Your power bill is not climbing. At the end of month 1, your electric bill arrives. If you normally pay $3.40 in June and July, your bill this month is $1.87. You have cut your cooling costs almost in half, and the system ran for an entire month. Your initial $6 investment has already paid for itself 9 times over. You will not break even. You will come out ahead. But here is what most people miss when they calculate the savings on a project like this. They look at month 1 and they do the math and they think, well, that is nice. Then they forget to multiply. Multiply that by 25 years. That is how long you will own your house. Multiply $1.50 average monthly savings across the cooling season by 5 months. That is $7.50 every single year. Do that for 25 years and you have saved $1.8.750 on one utility. That is a vehicle, that is a year of property taxes in many states. That is money that stays in your account instead of transferring to a utility company that does not know your name. And that is just the cooling function. Once you have the loop in the ground and you understand how to use it, the same system works for heating in winter. You reverse the flow or add a heat pump for $3 to $5 instead of the $8 to $1 2.00 that a contractor would quote. You tap the Earth's warmth instead of fighting the cold above ground. The loop becomes a year-round thermal bridge between your home and the most stable energy source available to you, the ground itself. Now, I know what some of you are thinking. You are thinking, this sounds too simple. Why is not everyone doing this? The answer is uncomfortable. The HVAC industry generates approximately $2.00 billion in annual revenue. The utility companies that your cooling bill flows to have lobbyists and marketing budgets that dwarf the advertising for entire industries. They have a vested interest, a massive, well-funded interest, in making sure you believe that climate control requires expensive equipment, professional installation, and monthly payments indefinitely. A gravity-fed ground source loop does not generate recurring revenue. It requires $6.00 and a weekend. It pays for itself in a single summer. Once it is installed, there is no ongoing cost, no service contract, no reason for the homeowner to ever think about the system again unless something breaks, which, statistically, something will not, because there are no moving parts except the water. If this were expensive, if it required annual maintenance, if it needed refrigerant refills or compressor repairs, or a technician's visit every spring, the industry would tell you about it. Instead, you have to discover it yourself through old research papers and agricultural extension documents and the stories of people like Horace Tatum, a well driller from 1926 who simply understood that the earth does the cooling work for free if you give it a pathway to do so. You have all of the knowledge you need right now to build this system. You understand the materials. You know why it works. You know what the installation looks like. You know what the savings will be. The only thing left is a decision. Are you going to let another summer slip by while you pay for air conditioning that you do not need to buy, or are you going to reclaim 2 days this weekend and take control? I want to mention something important before you start. If you want to go deeper on this project, and I mean really deep, with exact pipe sizes for different yard configurations, calculator tools to determine your specific savings based on your current electric rate, detailed cost breakdowns for winter heating conversion, and troubleshooting guides for problems that might come up during installation, we have a complete ebook guide available in the description and in the pinned comment. It covers everything from site selection to water treatment to connecting multiple zones. It is a paid resource, but it saves the guesswork and accelerates your installation by weeks. Let me give you one final thing to think about as you plan your installation. This is not a temporary solution or a trendy alternative to real air conditioning. This is the same technology that commercial agricultural operations use to cool grain storage facilities year-round. This is the same principle that kept food fresh in root cellars for thousands of years before electricity existed. This is not new, it is not experimental, it is proven. The only thing that is new is your decision to use it yourself. on your own property for your own benefit instead of paying someone else to manage your comfort. When August comes and your neighbors are complaining about their air conditioning bills, and you are sitting in your 74-degree living room without guilt, without stress, without checking the thermostat every 30 seconds, you will understand that this project was not really about the technology. It was about reclaiming something that was always yours, the ability to provide for yourself, to solve problems with intelligence and resourcefulness, and to stop accepting that rising utility bills are just the cost of living. You earned this retirement. You earned the right to live on a fixed income without watching it disappear into utility companies that did not exist 50 years ago. This project gives you a tool to actually exercise that right. It costs $6, it takes a weekend. The math works out to nearly $1 9.00 in savings over the life of your home. If you are ready to move forward, everything you need to know is in the complete ebook guide, the detailed installation instructions, the sizing calculators, the material sourcing list, and the year-round operation manual. Get it from the description or the pinned comment. Go deep. Build with confidence. I appreciate you spending this time with me today. This channel exists because I believe you deserve access to the same knowledge that the utility industry has been keeping from you, the practical, affordable methods to take back control of your energy costs and your retirement security. If you found value in this explanation, please subscribe to the channel, hit the like button, and activate your notification bell so you never miss a new upload. We release a new practical DIY energy project every week, and I want to make sure you see them. Thank you for watching, and I will see you in the next